Hello everybody. The topic of the presentation is consistent importing. And on the right side of the screen you have a QR code that you can use to download the slides and have it during the presentation if you wish for. And my name is Jan Bielecki. I work as a senior full stack developer. And a few facts about me in programming context. The first program I wrote, I was about 10 years old, inspired by my brother, who was into programming those days. And the first Python code I wrote, it was 10 years ago. And since 2019, I work with Python on daily basis. I use it at my work. And I work at Ørsted, and Ørsted is a global leader in offshore wind. And we have around 8,000 employees. Within those, we have around 1,000 IT specialists. And within those, we have around 100 Pythonistas, so people that would call or say that the main technology they use is Python. And the first section is about why I'm even talking about this topic. So in our current project, we have this strange re-exporting strategy. And my colleague asked me, who joined our project, why do we do so? And I actually couldn't answer. Another colleague introduced it and he was not working with us anymore. So I did some research to figure out what are the advantages and disadvantages of this approach. And this strategy look like this. We have an example of that. So let's say that we define a class node in the model geometry node module. And then what we do, we re-export it in the init.py of the package of the node module. Then we re-export it in the root package, so model in the init.py. And then from some other root package, we just import it directly from the model module. So there are some advantages of this approach. So there's kind of encapsulation of the whole root package. We have all the definitions as a single entry point, and imports are pretty shorter because you don't need to use full path to the module. You just used name of the root path. But there are obviously disadvantages, so you need to maintain that. You need to do it every time. Then IDE is confused because when you type node in any other module, it will suggest to import it directly from the module where it was defined. And it's hard to automate. I mean, you can write some script that will check if you do it like this, if you follow the strategy, but it will just introduce some complexity. And this approach has another advantage that I will talk about later. And what about consistency? So here's a photo of Mark Zuckerberg, and he just reduced one decision that he need to make during the day by one because he uses the same shirt every day. I mean, the same type of shirt. So we are not AI models, we are people. We have some amount of mental capability that we can use during the day. And if we can reduce some decisions, then those decisions that left, they will have better quality. And that's how Python wardrobe looks like when it comes to importing. So we can do it in many other ways. And if we don't follow any strategy, then you actually make those decisions every time you write code, every time you import. And this will be pretty boring section. You probably know most of the stuff here, but I hope the following section will be a bit better. So how importing in Python works. Let's start Python interpreter and define some function, and we can obviously execute it. It is successfully executed. Then when we exit the interpreter, we don't have access to the same memory anymore. So when we execute another Python interpreter, it's obviously not there. So that's why we have Python module. We can reuse our Python code. And if we can reuse it by importing. And if we import a Python module, we just execute all global statements from there. And if we get into a definition of a function, of a class, or a variable, then we save it as an object and put it as an attribute of the module that we import. So in this case, if we import my module, then just line number 5 will be executed. We have it printed and we can see what are the properties and methods of the my module object, because this my module is just a Python object like everything in Python. And you can see that we have a hello world there. And hello world is our callable, we can call it, and we can see hello. And then we have a Python package. So Python package is just a set of Python modules, put it into the directory, and together with those modules we can have sub packages. Another concept, good to know it, is system path. So system is a standard library and it has an attribute path, and path is just a list. And if we print it, we can see different directories there. And those are the directories that we look into when we import anything in Python. So if you would like to import some module in Python, you need to make sure that this module is inside one of those directories under syspath. And you can manipulate the syspath list. And the easiest way to manipulate it is a different way of executing your code. So you can execute it as a module when you put a -m flag and then path to your module with a import syntax. So using this dots instead of slashes. And then on the first place on your system path, you will have a current working directory. But if you execute it as a script, so just provide Python and path to this module, on the first place on the system path, you will have parent of the module that you execute. And there are other ways, like this is the most clean way to modify system path, but you can use other ways like setting Python path environmental variable. You just provide a set of paths there divided by colon, and let's just provide /example and anything can be here. And let's see what is under system path. You can see that they both landed at the first places, and if you don't put / then it's just treated as a relative directory, so it's prefixed with the current working directory. So anything can be here is prefixed with the current working directory. And actually you can put everything under system path. You can put boolean or any other object. It will still work. I mean, it's just a list, so you can append it, but importing, you will not break importing because of that. Then you have a concept of namespace package. So namespace package has been introduced in Python 3.4. And let's say that we have a situation that we have two packages with the same name. The name is my package, and they are placed in some path and some another path. And if in our system path you have both of those paths, then only the package from the first one will be imported. So if we try to import my package model, it will succeed. But if we try to import my package computation, it will fail. And namespace package can be helpful here, because to create a namespace package, you just need to remove the init.py file from both of those packages, and then they will just overlap. So the my package from some another path, we just overwrite everything from the my package from some path, and it will work. Now there will be a section about some recommendation, and part of those recommendations are from PEP 8, so a style guide, and part of those are just from my personal experience. And the first recommendation is to place your imports at the top of the file. Why? Because you are transparent about dependencies that you create for this specific module. Another recommendation is actually an exception to the first one. In this section, there will be a lot of exceptions. So there are some recommendations, but there are also a lot of exceptions from them. You don't need to put import at the top of the file, especially if it's heavy to load. So for example, PyTorch, it takes almost 2 seconds. If you would like to save this time at some conditions, then you can actually do lazy loading. What is lazy loading? You just import module right before you use it. So in this case, we import torch inside function evaluate model. Another recommendation is to not overuse type checking, especially to solve circular imports. So type checking is a flag that you can use, and this flag is only true if your type checker checks for the types in your code. But if you just run your Python code, it is set to false. So in this case, your IDE will be not confused with what is torch module. The suggestions about attributes of the module will still work. But on the runtime, you will not import torch at all inside this module. Yeah, so you can sometimes use type checking, but don't overuse it, especially for circular imports. And on circular imports, I will talk more soon. Another recommendation is also from PEP 8, is that imports should be grouped. So if you have those 3 groups, on default you have 3 groups, you have an immediate visual separation of your dependencies inside your module. So the first group is just a standard library imports, the second one is third-party imports, and the third one is your local packages. Another recommendation is to import 1 definition per line. And what for? Let's say that we have a module common constant and we would like to import 2 different definitions from there. We put it in a separate line just to reduce version control configs. It's a small thing, but if we can reduce merge configs, we don't like merge configs, so let's do it. Another recommendation also from PEP 8 is to use absolute imports. So on the default, absolute imports should be used because they are more informative, less ambiguous. But there are some cases like encapsulation, or you have a complex package layout, so you don't want to have imports that have 100 lines, 100 characters. Then you could use relative imports, but actually there's a note in PEP that standard library code should avoid complex package layouts and always use absolute imports. Another recommendation is to use only well-known abbreviation, so we know NumPy as NP, Pandas as PD. But if you introduce your own, make sure that everybody understands what does it mean. Another recommendation is to avoid using namespace packages. So the namespace package is this thing without init that can overlap sub-packages with another package that is named the same. The current recommendation is not to use it. So always on default put init.py in your Python package. There could be exception if you know really what you're doing and it makes sense, it will not introduce some uncertainty, then it's okay. Another recommendation from PEP is to avoid using wildcard imports. And wildcard import is this asterisk import. So with this asterisk import, what we do, we obviously execute the whole module as in every import statement. And then we save all the objects that we get from this module as the attributes of the module that we are importing to. So it will pollute namespace of our current module, pollute with who knows what. So it's better to avoid this ambiguity. But obviously there are some exceptions, and this exception was also mentioned in PEP. So we can have a situation that you have basic implementation of some math stuff, and then you have some accelerated implementation of this, but this accelerated implementation is only installed in some specific circumstances, for example, on a specific operating system, or only if you have a GPU. So you are not sure if you actually install it. You can have some proxy, let's call this proxy public API, and this proxy uses asterisk import to override all implementation from base implementation with implementation from accelerated implementation. And then in your script that you execute, you can use this proxy safely. And this is the last recommendation, and it's to import directly, import the definition directly from where it was defined. So this thing that I mentioned about the strange strategy that we have in our project, I would not recommend it. We here import node from module and not from the module that the definition is placed originally, so model geometry node. But there obviously could be some exception. and the exception is encapsulation. So you can have some kind of proxy, for example, proxy on operating system, and you actually import copy file on Windows, from Windows package or from Linux, depending on what system you are using. And then you can import this copy file from this proxy module and not directly from where it was defined. And now will be the section about how imports impact design of our code or architecture of our package. Why we should even care about this clean modular structure? It's first of all, it's more beautiful when you look at such a structure. You can at first glint get an idea of what is going on in this package, and you can easily remove stuff, move stuff around. You can easier find stuff or implement new stuff. And you can also run specific tools for a specific part of your code, for example, PyTest on some geometry subpackage or linting or icon subpackage. And here we see pretty clean design, modular design of our Python code. And yeah, it looks pretty. And the one advantage of this design, it's hard to see. You need to have more time to actually find out about this, but it does not have cyclic dependencies between packages. So it has a hierarchical structure, and it's easier to maintain code when we don't have cycles at all between our components, and in this case, between Python packages. And to do so do not have those cycles, we could follow a cyclic dependency principle. And here on the graph, we can see some of the components, interactors, authorizer, and entities that are coupled together. So there's a dependency cycle between them. And if you avoid such cycles, it will be easier to maintain your code. With such cycles, it's harder to test your code because those three components actually act like one single component. There's no boundary between those. And probably you know this import error due to a Silk Road import. And the question is if this is a bug or a feature of a Python. Because in Python, when we import a module, we just execute all of the statements there. So if we have a cycle between imports, then we will go to infinite loop of importing, because it will try to execute this one, then this one, then this one. So it's not possible. That's why Python check that and throw this error. But in general, it suggests that you have some design issue with your Python package. And it only works on the module level. So if you have circular dependencies between Python modules, then you will have this error raised. But with this re-exporting strategy that I mentioned at the start of the presentation, you will also not allow your software to have any cyclic dependencies between packages. Because let's say that we have this GUI and model as root packages, and now GUI depends on everything from his sub-packages, and the model depends on everything from his sub-packages. And if we import anything from model to GUI, it doesn't make sense that GUI depends on the model. But then when you try to import something from model to GUI, it does not make too much sense. I mean, why model should care about existence of GUI at all? But in this case, it will not raise import error because we don't have a cycles here. The imports are directed, and we don't yet have a cycle. But if we follow the strategy fully, so if we import directly from the root package, then we create a cycle. So another advantage of this strange method of re-exporting that we have in our project is that you cannot have circular dependencies between packages. Yeah, this is just a proof that it will not work. It will just raise the circular import error. And now the section will be about tools that you can use to enforce those recommendations that I talk about. And the first tool is RAF. If you don't know RAF, it's pretty cool because it's pretty fast and it's a linter and formatter. And to enforce the rules I was talking about, you just need this simple configuration file. So first we turn on isort to sort alphabetically our imports and group them. Then you have a rule about importing only at the top of the module. Then we have a rule about using absolute imports. Then we have a rule about not using wildcard imports. Then we have a rule about it's actually isort config rule about forcing ourselves to use single line for importing each definition. And we also have this known first party. I actually use it because in our project we have several packages in the root of our directory, so I need to explicitly mention all of them to not confuse RAF and IDE. What are my known first-party packages? Sorry. And going back to this re-exporting strategy, I removed this from our code. I didn't like it, but I would really like to save this acyclic dependency principle. And I was looking for a tool that can help me with that. And I find import linter tool. It's an open source tool. And in import linter, you can just define different kinds of contracts. And the simple contracts, it's contract of type forbidden. So we can just explicitly mention that GUI cannot be imported from module or DB modules. But I was looking for something more generic. I don't want to explicitly set list all of my packages. I just don't want to have cyclic dependencies between packages at all in my project. There was no such a contract, so we, together with the help of maintainers from import linter, we developed it. It's not yet released, but you can check it on my forked repo. And the configuration just looked like this. It's pretty simple. The one flag is pretty useful. So consider package dependencies. You can turn it to false, and then you check only for modular cyclic dependencies. You can check it to true to check the circular dependencies on package level. And I ran it on Django, and Django root package has more than 150,000 lines of Python code. And this is the outcomes. So in Django we have 167 cyclic dependencies, and within those we have around 88 cyclic dependencies on a package level. And now the question is, if Django will start now and they will use this acyclic dependency principle, will it be more fun? Will it be more easy to maintain this repository following the acyclic dependency rule when creating your Python structure? I think the answer is yes, but I don't have any data yet to confirm that. So I encourage you to check this out for yourself. Check if you have any cyclic dependencies. Probably you have some. Just to sum up, importing in Python can be done in many different ways, so it's nice to choose one because then you will reduce decision fatigue. And clean modular structure of your Python code matters. It has a lot of advantages, so it's nice to put some effort into that. Not too much, but some. And I think that following a cyclic dependency principle, it could lead to better software design, to better design of your package. And using tools like RAF and import linter, you can automate checks of those recommendations that I mentioned. That's all. Thank you very much for your time.